Let's look at an example of using the method of variation of parameters to solve a second order linear, in this case it will be a constant coefficient, non-homogeneous differential equation. So we're going to look at the equation y double prime plus 9y equals 9 secant squared of 3t. We're going to restrict our attention to t going from 0 to pi over 6 so that this is a continuous function on that interval, and since on this interval all of our coefficient functions are continuous, everything we've talked about before will work out beautifully. We'll expect a nice general solution that works on this entire interval. Okay, let's consider the homogeneous version of the differential equation. That's y double prime plus 9y equals 0. Remember, that has characteristic equation r squared plus 9 equals 0. That has roots r equals plus or minus 3i. That tells us we have solutions. I'll call them y1 is cosine of 3t, and I'll call y2 sine of 3t. And these will be a fundamental set of solutions to our homogeneous differential equation. We could check that with the Wronskian, which we know will be non-zero, but we're going to need the exact value of the Wronskian later anyway, so let's just figure that out. The Wronskian of y1 and y2 is just y1, which is cosine of 3t, times the derivative of y2, which is 3 times cosine of 3t, minus y1 prime, which is minus, that can't changes that to a plus, 3 sine 3t, times another sine 3t. This is just 3 cosine squared 3t plus 3 sine squared 3t. That's just exactly 3. So the Wronskian is a constant in this case, and it's the constant 3. Well, once we know the Wronskian, we can just write down a formula for these functions u1 and u2, where we want our particular solution to be u1 y1 plus u2 y2. In other words, that should be u1 times cosine of 3t plus u2 sine of 3t. So our formula tells us we don't have to go through the whole derivation. Our formula tells us we can compute the u1 just by taking minus the integral of, this is going to be our y2, and this is going to be our g of t. So that's sine of 3t times g of t was 9 secant squared 3t. And we divide by 3. Remember, that's the Wronskian here. And this integral actually simplifies pretty nicely. This is just an integral of the 9 over 3 is 3. So we have minus 3 integral of sine of 3t times secant squared of 3t is precisely sine over cosine. We take one of the secants to make it sine over cosine, which is tangent of 3t, and then we have left over a secant of 3t. So we have secant of 3t, tangent of 3t, dt. And of course you can recognize that the integral of secant x tangent x is just secant x plus a constant, but here we have secant 3t tangent 3t, so we need that factor of 3. We end up with minus 1 from there times the integral of 3 secant 3t tangent 3t is precisely, what is that, secant of 3t. You can check that by differentiation. I would write plus c, but I'm going to kind of ignore that because remember, when we're choosing u1, we can pick any antiderivative we want. We can ignore the constant. So I'm going to use u1 is just minus secant of 3t. u2 will be the integral of, here we'll have y1, here again we'll have g of t, and again in the denominator we'll have the Wronskian w. And that's just the integral of cosine 3t times 9 secant squared 3t over 3. The 9 over 3 gives us a 3. And cosine 3t times secant squared 3t is just 1 over cosine, or in other words, just a secant. The cosine cancels one of the secants. So I'll have the integral of secant 3t dt. And again, I should have left that 3 inside, because how do you integrate secant x? The integral of secant x is natural log of the absolute value of secant x plus tangent x. Now that's if you just had x here. We have 3t. With that 3, it's pretty easy to see that you'll have a 3t here and a 3t here. You could do a substitution where, say, x is 3t, and that would eat up the 3d with the dt, and you'll get this formula. Again, it would be plus c, but we can ignore that part. And here's another thing. I can ignore the absolute values. Why? Because right at the beginning of the problem, we stated that t was between 0 and pi over 6. So these are both going to be positive the entire time. So I can just write log of secant 3t plus tangent of 3t. I can take that to be my u2. And then what do we get for our y? Our y will be minus secant of 3t. Remember, that was our u1. That's this whole part with the minus sign, times y1 plus u2 times y2. And notice that secant of 3t times cosine of 3t is just 1, so we end up with minus 1 plus then sine of 3t times then the natural log of secant 3t plus tangent 3t. This is our particular solution. We're going to check that, and I really want you guys to get used to checking things. This might look like a mess to check, and it kind of is, but it's still worth doing to make sure you've done everything right. Let me tell you, I went through this problem by hand, and some errors were made, and then I checked everything, and I got everything to work out correctly. Always check your solutions. Trust me, you can make mistakes when you're computing the solutions. And what happens if mistakes are made? Well, if you're solving these differential equations to tell you how to build something, it could collapse and people could die. So check your work. It's very important. Lives depend on it. We're going to check that later. What's the general solution to our differential equation? And I'll remind you, that's for the differential equation, y double prime plus 9y equals 9 secant squared of 3t. What's the general solution? The general solution is y equals our particular solution, minus 1 plus sine of 3t times natural log of secant 3t plus tangent 3t plus c1 times cosine 3t plus c2 times sine of 3t. Just running out of space there. And that's the full general solution to this differential equation. Looks like a big mess, but it really works out quite beautifully. Let's check our solution below here. How can we check our solution? Well, we're just going to check our particular solution, because I'll assume you already know that the solution to the homogeneous is correct, and you can check that separately. So remember, we had y was this function here. I'll just write it. Y is this. So what is y prime? Y prime is precisely, well, the derivative of minus 1 is 0. We use the product rule to say we take the derivative of sine 3t, which is 3 cosine of 3t, times the second factor, which is natural log of secant 3t plus tangent 3t, plus, by the product rule, we have sine 3t times the derivative of this second factor. Now, that whole second factor appeared because it's the integral of the secant function, so we actually know that the derivative of this function is precisely 3 times secant of 3t. We had to integrate that to get that, so differentiating, we get back to that. So that's y prime, the derivative of our particular function, y. Y double prime is then the derivative of this, so we again just use the product rule here. we take the derivative of 3 cosine 3t to get minus 9 sine 3t times the log of secant of 3t plus tangent of 3t plus the first term here, which is 3 cosine 3t, times the derivative of this log of secant 3t plus tangent 3t, which we already determined was 3 secant of 3t. So now we've differentiated that whole first part. This product here, sine of 3t times 3 secant 3t, I should have said we can rewrite this as 3 tangent of 3t, because that's what sine times secant is. That's tangent, and we have that factor of 3. So when I differentiate 3 tangent 3t, I end up with 9 secant squared of 3t. And things are looking really good, because what happens when I take y double prime plus 9y? I get this thing as y double prime. And when I add 9y, that's adding 9 times this. Well, notice that the minus 9 sine 3t log of secant 3t plus tangent 3t, that when I add 9 times this term here, gives me 0. This term here is exactly 9. Cosine 3t times secant 3t is 1. When I add 9 times the negative 1, I get 0. So y double prime plus 9y gives me this plus 9y gives me 0, and I'm left with exactly 9 secant squared 3t, and that's a big old check mark. Everything works out beautifully. We have a good solution, which means our general solution was correct.